Can you let me know the rundown of what your project is and what you aim to do?
The current sort of goal we have is for people with disabilities to be able to move and actuate certain things like wheelchairs without having to use their arms or legs. And for example, one sort of way we can do this is with brainwaves. So if you think in a certain way and you measure the electrons on your scalp, the voltage, you will get a certain signal. And each sort of thought you have becomes a certain thought fingerprint, if you will. And if you sort of get AI and you classify each sort of thought fingerprint, you'll get a classification of movement. So it could be a car going forward or back, a robot arm going up and down. And so that's what we're doing. And we're hoping as this goes on with more project members and projects in the future, we might move on to wheelchairs, cars, any sort of actuation you can think of.
Can you tell us how the EEG signals are used to control the arm?
Of course. So when we have a thought and it gives us our unique thought fingerprint, you can sort of think of every side of your brain is turning on or off. Sort of if you've seen in a brain imagery, how some parts of your brain light up and some don't. And if you map that, you can get signals. And obviously the signals are still nonsense. So what you have to do is called frequency domain shift. So we're looking at things not in the time domain, but frequency domain. And this gives you the brain waves you've probably heard of. Have you heard of alpha, beta, gamma, and theta waves? So once you get these different things you can quantify, we just chuck this into an AI classifier model, and it gives us the movements we want.
As you can see in front of you, the EEG signals will convert via the AI classifier model into applying velocities. These velocities are created by the human's thought patterns with intent to grab the pipe. These velocities will then control the robot arm, which, as you can see in front of you, represents evidence that human disability can be circumvented using actuation of the mind. We'd like to personally thank MSDI, Monash Student Team Institute, and Motorola Solutions for providing the grant and support to making all this possible. Thank you very much.